All right. Hello, everyone. My name is Olivier Crête. I work for Collabora, and we help people build a product and solutions using open source software. I manage the multimedia team, which is a team doing with video and audio. So why open source, right? Why would we care about open source? There's two big things that I think really matter when it comes to open source. It's first and foremost, it puts the control back as close to the user as possible. So either in the user's hands or in the hands of the people actually developing products, so that even if you don't have to rely on suppliers to block your development process, you can already control things because you have the source code for everything and you can fix everything or make it work and not be stuck. And the other big one is long-term maintainership, right? If you have a product, you bought something, you put it out there, you have to maintain it for like years. If you have all the source code to everything, you can maintain it. If you don't, maybe you can't, maybe you don't. Maybe you're going to rely on some supplier that you don't know what's going to happen. So these are the really two big ones. Complete control also means complete flexibility. It's the ability to actually make the product or the service or the solution exactly as you need it to fulfill your exact needs. So open source these days is everywhere, right? Everyone who has an Android phone, that's full of open source stuff. The cloud, it's basically all open source, right? No one has managed to make any of this proprietary stuff stick in the cloud, right? People use containers, Docker, all these things. It's Linux everywhere, even Microsoft, even Azure, right? It's 2/3 is Linux now. Really, on the cloud, it's open source first. And embedded is the other end, right? If you buy a lot of embedded devices here, they run Linux inside, right? It's not, no one runs Windows on embedded devices. This is completely dead. So these are really the two main areas where we've seen growth in the technology industry in the last decade or so. And this is where open source is most prominent. So where is open source in the broadcast world? Well, you can find it across the entire pipeline, right? From capture to the end device. From like driving the camera, the sensor, all the way to TVs that the consumers buy. There's open source at every single step. And I'm going to go through every step and kind of give you a bit of an overview of what projects, which open source technologies are relevant at each step. But first, I'm going to talk about the two kind of big players that people know. First, ffmpeg, right? ffmpeg, it's a framework to build encoders, decoders, demuxers, muxers, packagers, simple streaming that's used almost everywhere. For example, every video on YouTube has gone through ffmpeg. When you use Chrome and you play a video, that's ffmpeg behind it, right? It's hugely capable. It knows almost every codec on the planet. And it's all open source, right? It's pretty unique in that sense. The other one is GStreamer. GStreamer is a bit different. So ffmpeg is all about the codecs, the formats. GStreamer is about creating pipelines to stream media through. The great strengths of GStreamer lie more on the network side. So getting data in and pushing it out, things like RTP, things like really about moving data across the network. This is where GStreamer great strength is. And when we want to actually in GStreamer to use a codec, specific codec, most of the time we call into ffmpeg to do that. So they're separate projects, but GStreamer uses ffmpeg a lot for what ffmpeg is good at. And for what ffmpeg is weaker, GStreamer has its own implementation. So they're two bits, and we'll see them across the pipeline because at many steps, they're actually one of the relevant players. So first step is capture. So capture is one where software is less prominent than in other bits because you actually need a physical piece of hardware, right? This is basically only step that hardware is really required because you need a sensor to capture the image or a microphone, right? You cannot just capture with software. And in this case, although many of the cameras actually might run Linux, The one that's pure software that people don't think of is something called OBS Studio. It's widely popular with YouTubers and esports people. A lot of the content that's on Twitch, for example, will have been through OBS first. It's multi-platform. And influencers for this in these industries, a lot of these use OBS to stream live. It's really, really easy to use, and it's quite reliable. And you just click, 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 and you can stream and do like simple compositions, overlay a camera over a video or vice versa. The second bit is, as I mentioned, a lot of these things run Linux. And on Linux, there is a standard API for video stuff, streaming media, and it's called Video for Linux. It started off as the API for webcams 20 years ago, and it has since hugely evolved. And now it can expose complex hardware that you have in modern cameras, where you not only have a sensor, but you have multiple steps of image processing before the image is actually usable. And Videos for Linux allows you to actually control all of these steps. But this is a complicated API because you actually need to control all of these hardware blocks separately. libcamera is a new project that tries to do over generic Linux what the Android camera HAL does for mobile phones. So it's basically abstracts all of these hardware blocks and has some code to integrate them together into something that actually gets you an image in the end, a nice image. So these are kind of more at the camera level, hardware level. Next, once we have an image captured, we want to send it somewhere. So that's where our contribution workflow comes in. There are many standards, but I'm not talking about standards today. I'm talking about software. So SRT is actual software you can download from the internet, from GitHub, right? There's another project that's called UPipe. It's a bit like GStreamer, but much more simple and aimed towards transporting media, streaming media, creating an MPEG transport stream and sending them and things like that. There's a couple kind of higher level project built on top of it, like OpenHeadend, which is an headend, OBE, Open Broadcast Encoder, which is an SDI to MPEG transport stream encoder, that are basically just built on top of UPipe. In this level, actually, ffmpeg and GStreamer do a lot of these things too, so they can actually use to encode and send and transmit over either SRT, but also other protocols, RTP-based protocols, etc., RIST. So at this level, GStreamer and ffmpeg are really relevant. Also at the camera level, so ffmpeg and GStreamer can actually control all of these Video for Linux APIs too. Next, editing, right? Editing, it's a desktop world. It's a place where open source is maybe a little less strong. So obviously, people use some proprietary applications from big vendors, but there are some open source ones that are quite successful. One of them is Blender. So yeah, one of them is Blender. Blender is mostly a 3D modeling tool, 3D production tool, but they also have a pretty complete editor now that you can actually use to do relatively complex editing. And there's a bunch of other ones that are more simple. They're more like on the iMovie level, if you want an idea. So they're not really professional tools, but they're kind of useful to do simple editing sometimes quickly. Almost all of these rely on two frameworks. So they're different UIs, but really, apart from Lies and Blender, all of the other rely on a framework called MLT or on GStreamer editing services. So these are two frameworks that allow in code to create a timeline and place clips in it, place your assets, and then render it. Both of them have a mode where you can actually use the UI, create your timeline, and then export it to a server where you can run it separately so that the final rendering can be moved to a cloud. There's also another interesting open source project called OpenTimeline.io. That's hosted by the Academy Foundation, that I'll talk about later, but actually comes from Pixar. And it's first a format to exchange information about timelines, but it's also an open source implementation to actually use this format. And we've implemented it in GStreamer editing services so that it can actually import timelines that were created with other tools, or export its timelines to be used in other tools. So it can be part of a whole editing pipeline. So now, once we've edited something, then we want to encode it, right? And there's a lot of open source encoders for different codecs. This is a small selection. Interesting bits in there are AV1, right? That's an open source codec developed as open source software. It was a software first codec. They first wrote the software. Then they're like, let's write a specification for it. It was always open source. I should mention that H.264.5 also was developed like that. But because of the patent issue, right, it's not the one that people actually use, the implementation. There's other interesting ones. SVT family of encoders from Intel. These are high-performance software encoders that Intel recently open sourced. They have one for HEVC. They have one for AV1. They also have one for VP9 that's receiving a little less love. But there actually have been a lot of work in the last 6 months on the AV1, HEVC one, achieving really high performance of encoding on server-class hardware. Very efficient at using like dozens of cores to produce a video. And the other one that's really interesting is Intel QuickSync. So that's been around for many years, right? All of our laptops and servers have it, this capability. But Intel recently open sourced all of the software bits that you can actually use. So previously, they only provided binaries, but now they open source not only the software bits, but also the compiler to take this source code and make it into machine code. So they basically open source the entire pipeline, which should enable more innovation there, because we can actually tweak it for different use cases. So that's a really, really interesting development from Intel. So once we've encoded our stream, it's nice, but that's just an elementary stream, right? We need to actually package it to distribute it. For this, there's many different things that you can use. GStreamer and ffmpeg are very capable. For many use cases, that's all you need. If you need something a bit more complex, you want to do HLS, you want to do Dash, you want to do like DRM, you want to add Widevine or other DRM systems, there's a project called Shaka Packager that's an open source project from Google that actually will take in a live stream and create all of these different packaging from the stream, all in software. And this is all open source and configurable and everything. This is pretty neat. And last but not least is Playback. So once we've at the end user, we have a stream, we want to play it back. And this is some place where open source is really, really used across the board, and no one knows it, right? You buy an LG TV, you buy a Samsung TV. This runs Linux. They have GStreamer in it. That's everything that's like not the HDMI input or TV, live TV, is going through anything that's smart, and the smart TV is GStreamer based on these devices. A lot of these actually have Chromium or WebKit as the web engine, and web engines are these days media engines, right? For a lot of these devices, everything happens in HTML5 with JavaScript to do the media processing. It's quite surprising what people do these days. I like to also talk about the RDK from Comcast. So it's probably the prominent now software platform for cable set-top boxes. Comcast has deployed it to millions and tens of millions of boxes in the US, but they're also shipping it to other cable operators around the world. And it's all open source. It's on the RDK website. You can download it. It uses GStreamer in the back end also. People know VLC, right? But there's also set-top boxes that use VLC for media playback. So there's libVLC there. It's not only the desktop application. It's also very capable. Then a lot of people actually don't use a set-top box anymore to watch their media, right? They use their phone, they use their computer, and for a lot of these, the player is just a web page, right? A web page with some really complex software in it. And there's dozens and dozens of open source ones. Some of these are from companies that are here today. Some of these are just from the community. And then there's mobile. I'm not even going to talk about mobile because there's so much more to do there. And there's so many open source projects for iOS, for Android, that are relevant. The next really important thing is these days, people have started working together. So for a long time, the media industry, the broadcast industry, the film industry has not been very open source friendly. It wasn't like the first thing that people would think about. But recently, the Academy, so the Academy of Motion Pictures, Art, Science and Arts, they've created a foundation with the help of the Linux Foundation to work together on developing open source software to interoperate between the different parts of the motion production pipeline. So now we have, this is real software. This is not just some paper with English words on it that different vendors implement different ways. This is the same software being used by the different vendors to produce data files that are interoperable. The foundation has a lot of members, big movie studios, Pixar, Disney, Warner Brothers, tools vendors like Autodesk, hardware vendors, Intel, NVIDIA, all the big guys are there. The membership is really impressive. Everyone who matters in this, the movie world is in that foundation. And they're basically enabling the studios also, the big studios who have their own software to interoperate with tools from the outside. So this is really the way it's going on. I should also mention Blender, right? When we talk about open source foundation, open source tools, they're in here, in Amsterdam. They write a tool to do video and 3D creation. They're doing the whole pipeline. They're also making their own movies that really showcase their tool and showcase that they have a whole system. These are all free movies, so it's not only the tools that's free, it's also the movie, the assets. You can go on the Blender cloud and download all of the assets and do whatever you want with them. It's a really, really cool tool that they're building. So we have all of these steps, right? But how do you bring them together? At Collabora, this is what we do. We help people take open source software and make them into a product or a solution through the entire cycle, from the very first step where we guide people, integrating them, optimize training, and long-term maintenance. So come visit us at our booth. We're just over there, 14.D15, so just 2 booths away this way. And if you're watching the video, you can contact us by email also. Thank you very much.